Hello, algebra students. Mr. Lawrence here with your review for the Unit 3 test. It might be a little bit long video, so I might split it up into two if this goes too long. But let's get right down to it. Now, I got to warn you, too many of you are just content to just watch this video and think you're going to learn. You can't learn just by watching. You have to get your hands dirty and do the problems with me. So right now, see problems 1 and 2 right there, adding and subtracting polynomials? You should pause the video and try to solve those. Don't just sit and watch. Copy them down, try to do it. All right, so here we go. Here is my solution. Again, hopefully you've already tried it. Remember that when I'm adding or subtracting polynomials, I'm more or less just counting. I'm just going to do my like terms. You'll see I've got a 5x squared here, and I've got a 3x squared here. Those are like terms. I got a positive 2x and a negative 6x. Those are positive, or like terms, excuse me. And I have a negative 7 and a positive 5, which are like terms because they're just constants. So now I'm just going to count. How many x squareds do I have? Well, I have 8 altogether. How many x's do I have? Well, I have a 2 and a negative 6. Now look, at this point in the year, you should be a master about this. We haven't used the calculators. If you're not mastering it, it's because you're not thinking about what you're doing. You're just trying to memorize. Look, you know that 6 minus 2 equals 4. Of course you do. Well, 2 minus 6 must be negative 4. This is too easy for you still to be getting this wrong at this point in the year. You have to think about it. You have to make it make sense. If you have to use a number line or something, whatever, but start getting it right. Okay, so we have a minus 4x and then a negative 7 and a positive 5. I'm not going to tell you how to do it. You're going to tell me how to do it. It's minus 2. And there we go. Now, problem number 2 is a little bit different because there's a negative in front of one of the quantities. What's negative? The 2? Well, yes, but the 2x to the fourth, this changes signs, this changes signs, this changes signs, and this changes signs. So what I'm going to do is I'm going to put a 1 there and I'm going to distribute a negative 1. Too many of you would just want to say, oh, the 2 is negative. No, all 3 of them need to be multiplied by negative 1. Actually, all 5 of them, huh? My mistake. All right, so this problem becomes 7x to the fourth plus 3x squared minus 5x plus 1. And when I distribute the negative, I get a minus 2x to the fourth, a positive 4x cubed, a positive 3x squared, a negative 6x, and a positive 1. All right, I can do my highlighting. X to the fourth and a negative 2x to the fourth. Let's see, 3x squared and a 3x squared, a negative 5x, a negative 6x, a positive 1, and a positive 1. Okay, now there's one term here that's kind of a lonesome term by himself. That's this one right here. I'll do him in a different color. Now you can use shapes or symbols or whatever. All right, so let's see here. The blue one, 7 minus 2, I must have 5 x to the fourth. Now this x cubed guy's all by himself, so he just comes along for the ride. 4x cubes. X squareds, looks like I've got 6 of them. My x's, looks like I have a negative 11x. Then my constants, I have 2. And there you go. There is the answer. It's not a solution because we didn't solve for anything. All right, let's see here. Distributing and foiling. Again, go ahead and pause the video at this point. See if you can do them on your own. Okay, here comes my solution. I'm going to distribute here, here, and here. So I'm going to get negative 6x to the sixth, a positive 10, that should be, positive 10x to the fifth, and then a negative 8x to the fourth. Okay, here I'm going to FOIL. I'm going to do my firsts, and I'm going to get, my first would be these two, right? And I'm going to get a what, a 6x squared. I'm going to do my outers. I'm going to get a 15x. That's my outers. My inners are minus 4x. And then my lasts are going to be negative 10. Now I have some like terms in there, don't I? I believe I do. So I'm going to combine my like terms, namely the 15x and the negative 4x, and get 6x squared plus 11x minus 10, and there you go. All right, hopefully you've tried 5 and 6 as well. My firsts are going to get me 42x squared. My outer is negative 35x. My inner is negative 18x. And my last, a positive 15. Looks like I've got like terms again. 42x squared minus 53x and positive 15. There it is. Now this one, don't make the mistake. Take the time and rewrite it. 5x minus 4 times 5x minus 4. 25x squared minus 20x minus 20x is a negative 40x and a positive 16. Excuse me. All right. By the way, if you're really sharp and paying attention, you'll notice we ended up with a perfect square trinomial right there. Right? Okay. Factoring. We'll first start off with the GCF. And it looks like the GCF of number 7 for the constant, the coefficient part would be 6. For the x's, looks like it's going to be x cubed. And for the y's, it's just going to be a plain old y. Okay, so now the GCF doesn't disappear from the problem. It has to go out front. This will have to look like a distribution problem when I'm done. So 12 divided by 6 is 2. X to the 8 divided by x to the third is x to the fifth. Y to the 6 divided by y to the first is y to the fifth. Here, 6x cubed y divided by 6x cubed y, that would be 1. And there's your problem. It's done. Okay, on this one, it looks like the GCF, it might be 6 again. I think it is. All right, GCF of 18, 12, and 24 is going to be 6. For the x's, it's going to be x to the fourth. Remember, you take the smallest exponent. The y's, it looks like it'll be a y squared. Okay. Oop, I forgot to put the x's in there. Guess I can tack them on at the end. It won't matter because I am using the commutative property. So I pull the GCF out front, and then I divide. So I'm going to get 3x squared, y squared. Here I'm getting negative 2x squared. Nope, x's are gone, sorry. The x's cancel, and I'll get a y cubed. And here I'm going to get 4, and the x's are going to be x cubed, and the y's are going to cancel. And there you go. All right, difference of perfect squares. By the way, when should you use a GCF? Always try to do the GCF first. Always try it first. Okay, difference of perfect squares. Well, and look, there is no GCF. Now, I know I'm going to use the difference of perfect squares when I have two terms. It's a binomial, and I have a perfect square minus a perfect square. Okay, so 16x squared is a perfect square. 4x is the square root. 9 is a perfect square, and they will always factor just like this. Two quantities. I put the square roots in 4x and 3, 4x, 3, and since there's a minus in the back, I have one of each, plus and minus, always, for a perfect square trinomial. Now, is this a perfect square minus a perfect square? It sure is, and you have an option. You could rewrite it as 81 minus 100x squared and do it that way, and then it might be easier. I'm going to go ahead and leave it the way it is to show you another way to do it. And so I'm going to take the square root of 100x squared, and that will be 10x. Square root of 81 will be 9. So I will have a 10x plus a 9 and a negative 10x plus a 9, because I need to have the 9's both be positive and the 10's one of each, because the 100 is negative. All right, 11. I have a perfect square. I have a perfect square, but I see no subtraction signs. There is no pattern for factoring the sum of perfect squares. This expression is prime. If you don't believe me, please try to factor it like this and then FOIL to check your work. You'll find you do not get x squared plus 36. If you think they're one of each, then you FOIL it. You won't get x squared plus 36. If you think they're both negative, FOIL it. You won't get x squared plus 36. All right, number 12 here. I'm going to try to pull out a GCF, and I see a 2x. So I'm going to pull out a 2x. Actually, I should divide them both by 2x, right, to show that. And so I'll have a 2x, and then I'll have an x to the fourth minus 81. Well, this is a perfect square, and so is this. So I'm going to take the square root of both of them, get x squared, get 9, and so now I'm going to have 2x, and I'll have an x squared plus a 9, and an x squared minus 9. Oh, and I'm done. Wrong, I'm not done. I fooled you. Look in here. Look, do you see it? I've got a perfect square minus a perfect square. The 2x is coming along. The x squared plus 9 is coming along. But I have the difference of perfect squares there. So, square root of x squared is x. Square root of 9 is 3. And then I need one of each. And there you go. Okay. I'm going to go ahead and pause the video there, and I will pick it up. No, I'll do the perfect square trinomials, then I'll stop. Okay, perfect square trinomials. That's when we have a perfect square for the first term, a perfect square for the last term, and the middle term is twice the product of the square roots multiplied together. Yeah, if you multiply the two square roots and double it, like for example, 9x squared, 3x, 16 is 4. Multiply them together, 12x, double it, 24, it matches. When that happens, it factors just like this. How did I know it would be plus 4 both times? Because when there's a plus in the back, it's the Wendy's double stack. This guy shows up both times. Okay, if he were negative, they'd both be negative. Now, some of you are wondering, could I rewrite it like this? Of course you could. All right, let's try number 14 here. Looks like a perfect square trinomial to me, but let's make sure. 5x, 6, 30x, doubled, 60x, sure enough. There's a plus in the back. It's the Wendy's double stack. Stop getting that wrong. It's too simple. This sign goes here, and it goes there. So, boom, boom, and I'm done. And of course, you could have written it like this, as one quantity squared. All right, one more for this video. 4x squared minus 40x plus 100. Remember, you should always try to GCF first. I'm going to pull out a 4. And I'm going to be left with x squared minus 10x plus 25. Looks like I have a perfect square trinomial hiding on the inside. Square root of that is x. Square root of that is 5. 5 times x doubled. Yep, sure enough. So I have the 4 out front. I'll have two quantities. And I'll have x and 5, x and 5. And you sing it for me. Go ahead, Preston. When there's a plus in the back, it's the Wendy's double stack. Boom, boom. All right, we're going to pause right there. That'll be video number 1, and then I'll have video number 2 for you. All right, Mr. Lawrence signing off temporarily. Good night, everybody.